Okay, good morning, ladies and gentlemen. Welcome to the International Visiting Lecture today with Dr. Chaitanya Singla as an Associate Professor from Chandigarh Group of Colleges, Jhanjeri, India. And for the topic today is database systems. You can start with pleasure.
Okay, have students joined? Okay, I am sharing my presentation, and after that, I am going to start the lecture. Just I am checking and tell me if my presentation is shared. Is the presentation visible?
Yes, sir.
Okay, thank you for the confirmation. I'm going to start a lecture on the database system. I was required from the audience that it must be a two-way lecture, not a single way. As the lecture stands, it must be an interactive lecture. So we are covering the topics normalization and Microsoft Access. First of all, in a database system, how we normalize the database and how we create a normalized database using Microsoft Access. First of all, the learnings from the topic and from the today's lecture is understand the concepts of normalization in database system, learn how to normalize the tables up to 3NF. There are a lot of normalization types. We are covering till 3NF, and then also gain a practical knowledge how to create a database using Microsoft Access and how to create it using and normalized it. So first question arises is what is normalization? Normalization is a technique of organizing the data into multiple related tables to minimize data redundancy and undesirable characteristics like insertion anomaly, deletion anomaly, and updation anomaly. Now, a lot of problems are there. First is data redundancy and these types of anomalies. How normalization solves this and why we are required to minimize data redundancy. And before that, what is data redundancy? So we are covering all these questions one by one. First is data redundancy. Data redundancy is nothing but a repetition of similar data at multiple places. As base is just a collection of tables, and table is in the format of rows and columns. Rows and columns. So repetition of similar data at multiple places like this highlighted cell that contains similar data is a problem. Why? Because it takes a lot of memory space. It also creates inconsistency in the data, and it also creates all these types of anomalies, list insertion, deletion, and updation anomaly. So first, why we want to minimize data redundancy to solve all these problems. Next question, why we need normalization in DBMS? Normalization is required to minimize the redundant data to solve all the problems. so that the database must be a consistent database. There must be a single value in each field. There must be minimum duplicate data, and every key must be uniquely identify all the other known key attributes of the table. We break down the tables into smaller tables to make the database more structured and linked every column each other in the tables. For example, I have a table, a student table in which there are total of 5 fields, or we can say columns. One is roll number, second name, third branch, fourth is HOD name of that branch, and fifth is last is office telephone number of the HOD. This table covers the information of the students and also the branch information in which the student is opting or studying. Suppose the student is studying in CSC department, we have in total of 4 entries or 4 rows as an example, in which there are 4 students. Uh, all the 4 students are studied in CSC language, CSC branch, and their HOD is Mr. X, and their telephone is 5337, let's say. So as per the diagram, as per the table, we are checking the data for branch, HOD, and office telephone is repeated, and this is known as redundant data, as this data is there for all the rows. Suppose, let's say, if in branch CSC there are 1,000 students, so for 1,000 students, this data will be inserted. So it takes a lot of space, it takes redundant data. So we have to solve this problem so that it does not create 3 types of anomalies. So first is insertion anomaly. Now what is insertion anomaly? Insertion anomaly is when we have to create a new row or a new entry. Like we are taking example of 100 students. Out of 100 students, if we are going through and we have to enter this detail 100 times, so there may be chances of redundancy or error. And if a new student taking admission, in and we didn't know the branch still now, we cannot make the entry, or we have to make the entry of null, as all the rows must be completed. That's why we can store this. Just 2 minutes. Okay. Sorry for the inconvenience, and let's start again. Suppose we, for a new admission, until and unless a student opts a branch, data of the student cannot be inserted, or else there will be branch information must be stored as null value. Also, if I have to insert a data for 100 students of the same branch, then we have to repeat this information 100 times. So this creates a insertion anomaly. Second is updation anomaly. Suppose the HOD leaves the campus, or it's no longer the HOD now. The position of HOD will be taken by Mr. Y. So we have to update in all the entries, or in the table where Mr. X is present as a HOD. So let's suppose we have 100 values, or we have in front of 4 values. Out of them, we change, or by mistakenly we miss one entry. It makes our data inconsistent, because in a database, in all the rows where Mr. X will be present as a HOD, we have to replace in all places to the new name, let's suppose Mr. Y, so that the database must be consistent. So there may be 100 times we have to change this name. This is known as update anomaly. Third is deletion anomaly. Deletion anomaly is if we by mistakenly delete a row, and by deleting that row, some other information, some other important information also lose. Suppose we have in our student table, there are actually two tables. First is student data and second is branch data. Along with the student details, the branch information of that student is also inserted in the table. If we delete all the students, so the branch information is also deleted. Suppose we have four students and all the four students are graduated now, and we have to remove the record of all these students from the table. If we want to remove these rows, after removing the rows from our college, the branch of CSC data is also removed, as there will be no branch. But our campus has the branch of CSC, and also the HOD details of that branch are also lost, because after deleting all the rows, the table becomes empty and there will be no rows, and along with student data, the branch data also lost. So this is deletion anomaly where by mistakenly we also lose some other important information that we are required. So to remove or these types of anomalies and data redundancy, we use normalization. How normalization helps to solve all the above problems? Normalization helps by splitting the table into two smaller tables or two relevant tables, so that our data or doesn't lose. We cannot miss any important data. There must be minimum null values. Our old student table consisting of five columns. First is roll number, second is branch, third is name, fourth is HOD name, and fifth is branch telephone number. So it consists of two tables data, branch data and student data. So we separate it into first is student data and second table is branch data. Student table consisting of roll number, name and branch, and the second table branch, HOD name and branch telephone number. We also take branch in the first table because we have to link both the tables. If we do not require branch in the first table, then it cannot be linked with the second table, and so the both tables are independent, but they cannot be linked. So we may lose the data. We cannot judge the roll number and the name belongs to which branch and who is the HOD of that student. So to link both the tables, there must be a common key attribute so that we can extract the data from by combining both the tables. How normalization solve? As per the previous example, we taken now with some entries or some rows. Suppose there are in the student table, there are three entries, and in the branch table, there must be a single entry because all the students belongs to a single branch, that is CSC, Computer Science and Engineering. So in this, how we remove all the anomalies? Insert anomaly, insert anomaly, update anomaly, and insertion anomaly. We remove this by dividing the table into two smaller parts. Now, first taking the example of insertion anomaly. Insertion anomaly, if we want to insert a student data, we can insert in the student table without any requirements of the HOD, and our redundancy is minimized because now only the branch data is redundant. No, we do not have. Earlier we have three columns whose data is comes under redundancy, data redundancy. Now only the data of branch comes under the data redundancy. Next, we have a branch table in which we have a single entry, not a multiple entries. Or for 100 students, we do not have the same information. We have only single entry. And now, if we want to change the name of our HOD to Mr. Expose, we have to change at only one place. So that's how our update anomaly is also removed. Update or modification anomaly. We can easily change or remove the name of Mr. Y to Mr. X. And also we can change the office telephone number. Earlier, the data is present for all the rows for all the students that are present in our database. But after normalizing the tables, we have to change it only at one place. And suppose the third anomaly is deletion anomaly. Earlier, if we delete the student data that is graduated, we also lose the branch data. But now, if we have three students and all the three students from CSC are graduated, we erase the data from the student table as we do not require. Along with that, our branch data is not lose. We do not lose the branch data because branch data is already in another table and we do not delete the branch table. We are only deleting the student table. The only student table in which student name and roll number is present, only that is removed, not the branch table. So through this, we are minimizing the redundancy, also removing all the three types of anomalies: insertion anomaly, update anomaly, and deletion anomaly. What are the key characteristics of a normalized table? For a normalized database, the many key characteristics, if a table is normalized, first of all, it must taken care of all these points. All these points must be available in that table or database. There must be a scalar values in each field. Field means a combination or interaction of row and column is known as a field. And in that field, there must be a single scalar value, or we can say atomic value, or we can say a single value is present, not a list of values separated by commas. Then the second is minimal data redundancy. We cannot say we eliminate all the data redundancy. We cannot say there must be a zero data redundant, but there will be minimal, not all the columns, or maximum there will be data redundant. Then third point is minimal use of null values. The values in the table must be minimal. There must be no every table column, every fields must have some values. And fourth is minimal loss of information. If we delete any row or values from the column or table, there must be minimum loss of the information. That satisfies our deletion anomaly. So that as normalization already deletes or removes the deletion anomaly, so the loss of information is also minimal. Before starting with the types of normalization, I go through a small quiz that consists of two questions only. So just go through it. And so I guess I also able to know that how much you cover this topic. And if you have any questions, then also you can ask me till now that why we need normalization and the types of anomalies. This is the first question. Are you able to see my screen?
Yes, sure.
Yeah. Yes, student, go to menti.com and then answer please this question so that it will increase the percentage how much students answer which option. Yes, ma'am. Are the students answering? Okay, they can also write on the chat board also. Yes, right now only three students answer this question. Else can also, if they able to, or they can also write on the chat window if they have permission. I am waiting maximum 5 minutes more. Ma'am, can you tell me, are the students writing in the chat window any answer? Okay, okay, let's go to the presentation mode. What are the types of normalization in this? There are in total six types. First is first normal form, then second normal form, third normal form, BCNF, that is boys code normal form, fifth is fourth normal form, and last one is fifth normal form. Most of the databases should be in 3NF or BCNF in order to avoid the database anomalies. Every higher level is a subset of the lower level. It means if the tables are in 3NF, they must agree the conditions of second normal form. And if the tables or your database is in 2NF, then it must satisfy the conditions of first normal form. The tables must be in first normal form, then only it can switch to second normal form or third normal form. If the tables, if you want your tables or database to be in fourth normal form, then it must be in 3NF, then only they can go for fourth normal form. That's why the every higher level of the normalization is a subset of the lower level. So next, what is first normal form? First normal form stays. First normal form is considered, a table is considered to be in one NF if all the fields contain only scalar values as opposed to the list of values. It means the table must occupy a single value only, not the list of values separated by commas, like as in the example shown. The table in the column 1 must have a single value A, second row consists of B, third row consists of C, but in the column 2, there consists of two values X, Y for a single field. So for that, This table is not in 1NF. The table must consist only a single value or a null value if it wants to be in 1NF. All the values in the fields are atomic. Second rule, the table in a table, the data type. Every field has a certain data type. Suppose date of birth is for text or name is for text and phone number is for number data type. There are a lot of data types. We are discussing that types of database when we are creating a database using MS Access. Column must contain the same value of the particular data type. If the data type for that column is number, the column data must be of number data type only. We cannot store text data type in that column because the data type of that column is number only. Third rule says that the column names or the field names must be unique. There must be inconsistency, there must be error when if we are taking the same names when we are querying on that database to fetch the values. We use SQL queries, structured query languages for the RBDMS database to fetch the columns or the fields for the values based on the column names. So if the column names are same, the query is unambiguous and it does not understand which column he has to pick for to fetch the values. Rule number 4, it says that the order must, there is no specific order. You do not need to specify a particular order to enter the values in the row table because there will be a key that is a primary key which through which you can fetch all the other values of the columns for a particular key using that key. Suppose if we want to fetch the first name or the last name of the roll number whose roll number value is 4, I can easily fetch the first name is S and the last name is K. Primary key is a unique key in a table through which we can fetch or identify all the other values or all the other columns present in the table. Other than primary key, other than the key attribute, all the other columns that are present in the table are known as non-key attributes. So in a table, there must be two uh, uh, types of columns. First is key attributes that consists of any primary key, candidate key, super key, or a part of key, and other that not part of that key are known as non-key attributes. So taking this example, the example is not 1NF because the column named AU name and AU phone, these are the two columns which store list of data. These columns does not store a single value similar as for title column. All the four rows considered a single value. For pub name, all the four rows containing a single value. But in case of AU name and AU phone, there are multiple values separated by commas. So that's why, because of these two columns only, the complete table is not in 1NF. To make this table in 1NF form, first normalization form, we have to make these columns containing all the rows a single value. There are multiple ways through which we can make this table into 1NF. First is we can decompose the table into smaller two tables. Secondly, we increase the number of rows and make some data redundant. And for every entry, there is single value. Likewise, we are getting some examples. This table, the above table, we can decompose into two smaller tables. Now you can check every entry in the two tables containing a scalar value and atomic value. Place all the items that appear in repeating group in the new table. AU name and AU phone. We create a new table and make it all the comma separated values. Make a separate row for all the values. Then designate a primary key so that these two tables must be interlinked to each other. There must be a common column so that we can link these two entities. Then we can create this. Now both these tables are in 1NF form because all the values stored in these tables are atomic. The other example is through which we can do so to make the table in 1NF is, let's suppose another example for a library consisting of two columns in which one is student ID or patron ID and other is the number of books that borrowed by patron ID, that particular patron ID. So borrowed books C45 named student ID borrowed three books and the C12 borrowed only a single book. Because of this entity or this value in this field, this table is not in 1NF. So to make it in 1NF, we increase the number of rows to make it 1NF. For this, the data in the pattern ID may be redundant as for the C45, there will be three rows now. Earlier, it was only single row, but now there will be three rows. In the previous example also, for AU name and AU phone, for every value, there will be a single entry. So now this way we can make a table in 1NF form. The next is 2NF, that is also known as second normal form. The main requirements to make a table in second normal form are two. First, the database must be in first normal form, as we already discussed that, and all the known key attributes that are not part of your key must be fully functionally dependent on the entire primary key. Now, entire primary key, what does mean? Primary key consists of a single column also. Primary key consists of multiple columns also, that is more than one column also. If a primary key consists of a single column, it means a single column can identify all the other columns present in the table. For example, roll number or student ID present in the student table. From the roll number or student ID, we can uniquely identify all the other columns or all the other fields present in that table. Now, maybe there will be chances for some database or some tables that their primary key consists of more than one column. If the primary key consists of more than one column, it means combining columns can two or more than two columns can uniquely identify all the other columns present in the table. So all the other columns must be fully functionally dependent on the complete primary key. It means complete both the columns, not on the subset of the primary key. If any other attribute, non-key attribute present in the table is dependent on the subset of the primary key, then there will be partial dependency. So to make the table in 2NF, there must be no partial dependency, and all the known key attributes must be fully functionally dependent on the complete primary key. If the primary key consists of more than one column, so there must be a logic. If that in your table the primary key consists of a single column, then the table must be in 2NF. If and only if there will be it covers a single requirement, that is the table must be in 1NF. If the table is in 1NF, then it automatically satisfy the condition of, to be in 1NF, and the second condition is also satisfied as there is only one column. All known key attributes must dependent on a single column only. There will be no subset. So for that reason, if the table consists of only a single column, automatically the table must be in 2NF. So taking with an example, we are going through. Suppose there is a table in which student ID does not identify all the key attributes, all the known key attributes, as there are two names with same attributes. There will be registration number, branch, and address. Now, if any way registration number or the branch or address is dependent only on the name or the student ID, if student ID and name both are primary key, then there will be a partial dependency. If and only if the primary key consists of more than one column, then there exists a partial dependency, otherwise not. To remove this partial dependency, we have normalization. How we can do this? Let's take this with an example. For we are taking this example. The example is not in 2NF, as there is a schema which contains these column names. There are 5 column names in the table. Let's suppose first is title, second is pub ID, third is AUID, fourth is price, fifth is AU address. Then the key attributes is means key attribute means the primary key consists of 3 columns. First is title, second is pub ID, third is AUID, and all the other attributes present in the your schema or your table are known as known key attributes. So the functional dependency is there is price, fourth column is price is dependent on complete key. AU address is dependent on only AU ID. AU address is not dependent on title. AU address is not dependent on pub ID. So this arises a partial dependency because AU ID is the subset of the complete primary key. If AU address is dependent on the complete primary key, then there must be no partial dependency and the table must be in 2NF. But now the case is AU address is only dependent on the subset of complete primary key, that is AUID. So for this reason, the table is not in 2NF. AUID and AU address, only these 2 columns which are interrelated. So we decompose this into 2 smaller tables. Our old schema is in which there are 5 tables, but the new scheme, when we divided these 2 tables, is we take title, pub ID, OUID, comma price, and the second table is AUID and AU address, which column that is now the complete two new tables in 2NF as AU address is dependent only primary key, a single primary key, AU ID. This table is in 2NF. Price is dependent on all the three columns. So this table is also in 2NF. So to make the table in 2NF, there must be no partial dependency and all the known key attributes must fully dependent on the complete primary key. Is there any doubt till now? Is there any doubt till now?
Yes, sir.
Okay. Then there will be third normal form. Third normal form is for the table to be in three normal form, there will be two requirements. First is table should be in second normal form and there no attribute is transitive dependent on the primary key. Now, what is transitively dependent? We say that if B is dependent on A and C is dependent on B, then we can also say C is dependent on A to B, B to C, then A to C. As in example, this title and pub ID is the key. Page count is dependent on title and pub ID. Price is dependent on page count. So automatically title and price pub ID to price. This is known as transitive dependency. Means A to B, B to A, B to C. This is suppose, let's say we can say that this is A to B and then this is B to C, then it automatically arises A to C. This form is known as transitive dependency. So a table to be in 3NF, there must not any transitively dependent and the table must be in second normal form because every higher normal form must be a subset of lower normal form. Okay, I will take the questions. Just I am completing this 3NF as I am seeing some questions on the chat window. Just give me 5 to 10 minutes. I am completing this three normal form and then I am get back to you the questions. So the table must be in 2NF and the second is transitive dependency. A to B, B to C, and then automatically it comes to A to C. So these for this we have a simple normalization, just breakdowns through normalization, we just break down the tables into smaller tables so that the table must be in normal forms. Second example, and there must be a third example also. Suppose we are taking the third example in which there is a table. One is building, second is contractor, third is fee. Okay, just give me 2 minutes. I put battery on my laptop. Thank you. And sorry for the inconvenience. Now I am taking this example 3, that is example 3. And in this example, we have a table. The first is building, contractor, and fees. In total, there are three columns, and building ID is the primary key. So this table is in 2NF as first it completes all the requirements of 1NF as all the values present in this table are single values, atomic values. So this table is in 1NF. For second NF, as there is a primary key consisting of only single column. So that's why also this table is in 2NF. Now we are checking for 3NF, that the table is in 3NF or not, because the contractor is dependent on building and the fee is dependent on the contractor. Fee is not dependent on the building ID. So there arises the situation of transitive dependency A to B, B to C. So that's why this table is not in 3NF. So to make this table in 3NF, we further split this table. We further split this table into two smaller tables. First is building ID, second is contractor, and the second table contains two columns. First is contractor, and second is fee. So by making these, we will convert these complete tables in 3NF form. Now I am taking these questions. Yeah, first question is from Abdul. What are some best practice for ensuring data integrity and consistency in large scale databases? First of all, uh, for the data integrity and consistency, the database must be normalized, the normalized form, and it also follows all the integrity rules that comes with they must satisfy the uniqueness of the primary key. Also, it must satisfy the foreign key conditions. That is, it must follow a parent-child relationship between the two columns that consists between a primary key and a foreign key. So, for that reasons, we can consider the database to be contain the data integrity and database must be consistent. For the large database also, allow the latest technologies as per the latest technologies like MongoDB, in which the data entries are stored in the form of documents. There must be a document ID present for every document, and so that it automatically ensures and the integrity of our database. Using that, the conditions automatically exist and it also removes the inconsistency of the database. Second question is from Kinan. It says that could you explain how ACID properties apply to database transactions and why are they important? Let's take a small example of atomic and consistency database. Let's take the example of a bank transaction. Suppose we have two persons, A and B. A wants to transfer some amount, let's suppose 100 rupees to B, and A transferred the amount. So there must be a transaction in the database of A as A transferred the money. So there must be a deduction of 100 rupees from A's account, and in B account there must also have a transaction that covering the 100 rupees of increment in their balance account. So when we are taking A and B, if the value of A is deducted and meanwhile due to some technical problem or the network problem, the same amount is not reflected in the B's account, then there will be a error because After taking the count of the accounts, the amount must differ. The amount deducted from the A's account will go nowhere, as B must be credited with the same amount, but B is not credited. B person must ask from A that where must be the amount. So for that reason also ACID properties must be followed, so that if a transaction is there, it must be a complete transaction. Otherwise, it must reverse back. So for that reason only, the amount of A must be reversed in the A's account only if it does not reach to the B's account. Meanwhile, there are a lot of other examples also for which these ACID properties are important, because in the large databases, if we do not commit, we can also roll back the complete transaction. By anyhow, in the larger companies, a data scientist or database engineer may delete some entries. So if it does not commit those, we can again find those rows. A transaction must be complete in a that then only it must be a complete transaction. Otherwise, it must be zero or complete case only. Mean, I hope I can answer all the questions, and it clears to the student. Now, only as per my screen, only one question is pending of Paulina. If there will be any other question also, you can tell me.
Okay, thank you so much for your answer and presentation, Sir. I guess no one is asking again. Yeah, maybe you can continue in the last slide.
Okay.
Yeah, thank you.
Then for the last slide, it's just a question for the students that to check that this table is in 3NF or not. Uh, as we cover only normal form till 3NF, so we are checking this database that consists of three tables is in third normal form or not. Students can answer me in the chat window also, or if they have permission, they can speak. Students have time of 5 to 10 minutes for this to check in all the conditions that for this table is in 3NF or not, or this table is in which normal form. The columns highlighted in red are the primary key for that table, and all other columns that are highlighted in blue are non-key attributes. Okay, I am waiting for 5 minutes. Yes, ma'am. Do you receive any answer from the students? Okay, I'm still waiting. As I received no answer from the students, so I'm telling the tables shown in the screen are not in 3 and F form, and the tables in the screen showing are in 2 and F because for the first table, that is student table, will be only a single primary key. So all the known key attributes dependent on that only. So student table is in 2 and F. When there will be no data, only the column names will be there. So we are assuming that this column contains only the atomic values. That is, there will be a scalar values, only a single value for each column. So it must be in 1 and F, table in 2 and F also, student table. Then we are taking the second table, that is core table, in which the primary key is consistent of two columns. First is student ID, and the second is subject ID. Combining these both two columns, all the other key attributes are dependent on these. Core ID is dependent on student ID and subject ID, as which student and for which subject the student is scoring the course, and how many marks, and which were given by which teacher, and teacher of which subject. So the second table is also in 2NF because all the other known key attributes are fully functionally dependent on the primary key, complete primary key, the entire primary key, not on any subset of the primary key. And the third table is subject table. So all the known key attribute, that there is only one single attribute known key and a single attribute that is primary key. So subject name is dependent on subject ID. So for these three tables are in 2NF but not in 3NF because due to the table of core table. As core table, there is a column named teacher that is creates a transitive dependency as marks is dependent on student ID and subject ID. Similarly, score ID is also dependent on student ID and subject ID. But teacher is also dependent on the marks and subjects, which creates a transitive dependency in this. So we have to remove the transitive dependency for this table to make the complete database in 3NF form. From this slide, this is the last slide, and if you have any questions in normalization up to 3NF, you may ask. And if you want to create a new database using Microsoft Access to check how we can create it, we can go ahead for that also. If you have any questions, you may ask. There is one question from Anto that is, what are the CAP theorem principles and how they can influence the design of distributed systems? First of all, in the database, there will be two types of system. First is database is centralized and the database is distributed. So based on that, it may influence the database. There is another question from Amelia. Could you elaborate on the concept of foreign keys in relation to and foreign keys are just creates up in between the two tables to link the two tables to create a parent-child relationship. And if we are creating a parent-child relationship in the child table, basically that in which the foreign key is created based on a primary key that is available in the parent table, all the values that that column contain must be null value or the value from its parent table only. Like for example, if we are having a parent in a college and we are having a database of two tables, first table contains the student records data in which all the values that are present related to the student data, like student ID, student name, student father name, student email ID, etc. And in the second table, we have a find record that is applied against that student. Pause for any type of fine that will be applied to that. So if there will be no student with student ID, then how can we impose a fine to that? So the second table in which we have stored the fine details for that particular table, we have a foreign key column, which is student ID that must take a value from its parent table that contains the student records. Because if the student roll number is present in the student details, then only it will be the part of that college and else it will not. So any student that is not part of the college or that does not have any student ID, how can we impose a fine to that? So for that reason, there must be a concept of foreign key, and using that, we can create our data integrity and data consistency so that our database must be following the and linking from all the tables. I hope it satisfies your question. Okay, the next question is from Kohar, that is, what are the trade-offs between a normalized schema and a no denormalized schema? Suppose we are having a denormalized schema in which there must be a redundancy. Suppose we are taking the first example in which the HOD name, the telephone number, and the branch is redundant. So when we are querying to that such a high definition or high data entry database in which there are entries in terms of lakhs or thousands, we are querying to such database, then it will take as much time to process that database because it will go through to all the thousand entries, 10,000 entries to check, and we have so it takes so much space. In case of normalized schema, we have a particular primary key through which we can just query a condition based on that primary key, and we can automatically fetch a particular value that we want for another column. We have to search for that a single value which can completely identify all the values from that table. Uh, in other condition, in other part, when we know using a normalized schema, a key disadvantage of a normalized schema is when we split the table into smaller multiple tables, we have to use the join condition to join all the tables and creates fetch the data from multiple tables. Using join condition, the query, SQL query makes complex. So this may be a key challenge for a normalized schema. Any other questions, please?
Okay, thank you so much. I guess no one else is asking again, sure. Yeah, before I close this event, yeah, for our participant, please open your camera. I will take a picture on the phone three. Okay, one, two, three. Okay, another one, two, three. Okay. And for the presentation, this is enough or not sure?
Yes, ma'am.
Okay, okay, thank you. Yeah, thank you so much. Yeah, finally, we come to the end of this lecture today. We'd like to thank you for Dr. Chaitanya for the wonderful information and sharing your knowledge. We hope this information will be beneficial for our participants. At least we hope to have more collaboration in the future with Chandigarh Group of Colleges India. The visiting lecture for today and here. We hope to see you soon. Thank you and finish day. Thank
Thank
you
you,
so
ma'am.
much,
Thank
Chair. Goodbye.
you.